8.0 Prerequisite Skills under Represent Quadratic Relations. Okay, so if a graph is a straight line, then the relation is linear. And if a graph is a parabola, so remember parabolas look like this, happy faces, right? The relation is quadratic. Okay, and if the graph is not a straight line or a parabola, the relation is just simply neither linear or quadratic. Okay, so number one, graph the relation to determine if it's linear, quadratic, or neither. Okay, then we're also going to fill in the first and second differences. Okay, so I'm going to go up this axis by 2. So 2, 4, 6, 8, 10, 12, 14. Okay, and then I'm going to go up this axis just by 1. So 1, 2, 3, 4, 5, 6. Okay, so -1 and 16. 16 is a little bit off our graph. 0, 2, 2, 4, 3, 20. And that's going to be way up here. Okay, and then 4, 46. Okay, so just taking a look at this, it kind of looks quadratic. Okay, we know a lot of times when we have a quadratic relation, we're given nicer numbers such as like the vertex, which is that turnaround point, or our numbers down the y-axis are symmetric. Okay, but it doesn't always necessarily need to give us those like easier numbers. So let's go ahead algebraically and find the first and second differences. Okay, so the first differences, just as a review, we're going up the y column and we're subtracting 46 minus 20, so 26. 20 minus 4, so 16. 4 minus, and be careful here, we have -2. Let's be here. Okay, and that's 6. -2 minus 2, and which is -4, and then 2 minus 16, which is -14. Okay, we can't subtract this by anything, so this box gets shaded in. And then the second differences box, it's 1 even less. So every time you do a difference, it's 1 less box that we have to fill in. Okay, now for the second differences, we're going to go up the first difference column right here. So we have 26 minus 16, I get 10. 16 minus 6, I get 10. 6 minus -4, I get 10. -4 minus -14, I get 10. Okay, so if we take a look here in the second differences column, okay, these are constant, so these are the same number. Same number. Therefore, this is quadratic. Okay, when a question asks us to find the solution, it means the point of intersection, okay, to each linear system. And what a linear system means is just 2 lines. That's it. Okay, so when 2 lines are on a graph, do they intersect? And if so, where? Okay, so for A, we have a point here where the 2 lines intersect, and that point is 1, 3. And on the second graph, we have a point here where the 2 lines intersect, which is 3, -3, or -2. And then that's it. Okay, example 3, substitute the known value into the equation, then solve for the indicated variable. Okay, so we're going to find the value of x when we sub in y equals -2. So we take this -2 and exactly where the y is, we sub in -2. And everything else, we just bring down and copy it out. And now all we have to do is rearrange. So I'm going to bring this 7 over, and because it's +7 and it comes over the equal sign, it's going to change to -7. Okay, so -2 minus 7 is -9. And this one I just rewrite 3 times. Okay, so I'm just bringing that down. And now I can divide both sides by -3, and I get x equals 3. Okay, now B, find the value of y. So that one's easy because the y is already isolated here. Okay, when x equals -1. So remember in this, especially because there's a squared here, we want to bracket that -1. If you don't bracket it in your calculator, there may be an issue with like a positive or a negative when we square -1. Okay, so -1 squared is actually 1. So we have 2 times 1, and then -3 times -1 is +3, and then just bring down that +4. So in other words, 2 times 1, we have 2 plus 3 plus 4, 4, 5, 6, 7, 8, 9. Our y is 9. Okay, next, when multiplying two binomials, we use FOIL. Okay, first outside, inside last. Okay, so in example 4, expand and simplify each expression. So we have a monomial multiplied by a binomial here. So all we're doing is simple distributive property. So we distribute this -2 into the bracket, and we multiply -2 times 3, which is -6. And we also have to multiply the x times x, which gives us x squared. Now we multiply the -2 by the -5, which is +10. And we have an x there, so we just put an x. And then that's it. Okay, this is the binomial question. So the first term, when we FOIL, we have to multiply the first term in this bracket by the first term in the second bracket. So we get x squared, right? X times x is x squared. Now the outer one, so this one and this one. So x times 5 is 5x. Okay. The inner ones, -3x. And then the last, -3 times 5, I get -15. Okay, when we're at this point, all we want to do is we want to add these two terms inside the bracket. So I get, bring down the x squared. I mean, you can bring down the -15, but then this middle term changes to 2x. Okay, example 5, factor each polynomial. So when we factor, what we want to do is, for the first two here, a and b, we want to find a number that both terms divide by. So we can divide -2 and 12 by -2. Okay, if this leading number is negative, we always want to pull that negative out. Okay, and then the 12 doesn't have an x, so we just leave the x's. Okay, so we want to bring down our factor and put everything else into brackets. So those cancel, and we're left with x squared and then -6, right? 12 divided by -2 is -6. Okay, the second one. So 5 and 12 don't divide by the same number, but we have an x squared and an x. And the rule is take out the lower or the lowest, depends on if you have more than two terms, the lowest exponent. Okay, so the variable with the lowest exponent is x to the 1. So we bring that common factor out here, and we're left with, in the bracket, 5x minus 12. Okay, a little bit different for C. In C, we have a trinomial. So we want to find two numbers that multiply to 12, and then add to this middle number. So with this 12, I sit here and I list all the factors of 12. And then I look at them and I say to myself, which ones add to -7? Okay, well, 3 and 4 add to 7, so -3 and -4 add to -7. Because this is a trinomial, what we want to do is make two brackets, and we have x minus 3 and x minus 4. Okay, so these factors here go directly into the brackets. Okay, example 6. So for each parabola, we're going to identify the vertex, the equation of the axis of symmetry, and the x and y intercepts. Okay, so let's call this one A. Let's do A first. So the vertex is 2, 1, and the axis of symmetry is this number right here, x equals 2. Okay, the x-intercepts are 1 and 3, so we can say x equals 1, 3. And the y-intercept occurs here. We can call this 0, -3. Right? Another way of writing x-intercepts would be 1, 0 and 3, 0. Okay, and let's call this one B. So the vertex is 2, 1, so the same, which makes the axis of symmetry the same, which is the 2, x equals 2. And if we look at the x-axis, there are no x-intercepts, so we just say none. And if we look at the y-axis, we can identify right here, 0, 5 would be the y-intercept.